Lesson 1.2.1, Speed and Velocity. We'll start this lesson by looking at the quantity speed. Speed is a measurement of how fast an object is moving. Speed is a scalar quantity. This means that we don't use direction in our calculations for speed. Direction doesn't matter to speed because it's a scalar. The symbol we use for speed is lowercase v, and the unit is the meter per second, m/s. Most of the time we're looking at objects that change speed. In the real world, objects don't really travel at constant speed. So we often are calculating for average speed. Average speed is when an object is moving at a series of different speeds or a bunch of different speeds in a particular time frame. We can calculate average speed. There's a formula for average speed. It's probably one you've seen before. The formula we use for average speed is V average equals delta D over delta T. This little triangle symbol that you see there is Greek letter delta. Delta is placed in a formula to signify that we mean change in the symbol it's next to. Delta D, for example, means the total change in distance. Very important in this definition is the word total. Total means we add up all the distances traveled. Delta T means the total change in. The delta reminds us that it's a change in time. This is measured in seconds. Before we move on to some examples, let's also look at the quantity velocity, which is slightly different than speed. It has a different definition and it's calculated slightly differently. Velocity is how fast you are moving or you are leaving your start position. And the direction you are moving. Key in this definition is the word direction, which tells us that velocity is a vector. We do have to consider direction when we're doing calculations for velocity. The symbol that we use for velocity is also a lowercase v, but in this case with a vector arrow over top. The unit is the meter per second. Average velocity is similar to average speed. Average velocity is calculated when an object changes speed or changes velocity during a trip. And there is a formula we can use to calculate the average velocity. The average velocity formula, V average equals triangle D, or delta D, over delta T. Delta D is the total change in displacement. Delta T is the total change in time. Now here's an example. A car travels 500 meters north in 105 seconds. And then makes a U-turn and travels back 300 meters to the south in 87 seconds. What is the average speed and velocity of the car? The first thing we do is calculate the total change in distance. This comes from the 500 meters and the 300 meters. 500 meters plus 300 meters equals 800 meters. Because distance is a scalar, we could just add the numbers together. The total change in displacement does have to take into account direction. This is 500 meters to the north plus 300 meters to the south. Changing the directions into signs, we get positive 500 meters plus negative 300 meters, negative because of the south. This equals positive 200 meters or 200 meters to the north. The total change in time is 87 seconds plus 105 seconds. This equals 192 seconds. The average speed is calculated by change in distance over change in time. This is 800 meters divided by 192 seconds. This equals 4.2 meters per second. The total velocity average is equal to displacement over time. The displacement was 200 meters to the north. Divided by 192 seconds, the total time doesn't change. This equals 1.0 meters per second to the south. Don't forget to put a direction on your vectors. The south is an important part of the answer. Here's another example. Let's think about a dog running around a field, and it doesn't run in a particularly straight line, it just runs around and has a lot of fun while it's doing it. In this pretty crazy trip, there's just a very tiny displacement. Just the distance from start to finish is the displacement. Here's the question. A dog runs around a field. Even though the dog travels or covers 400 meters distance in total, he only ends up 2.5 meters to the south of his start point, or of where he started. This trip takes the dog 300 seconds. The average speed is the change in distance over time. This is the 400 meters divided by 300 seconds. And this gives an average speed of 1.33 meters per second. The average velocity is change in displacement over time. This is only 2.5 meters to the south divided by 300 seconds, which is 0.0083 meters per second to the south. So even though the dog is traveling at a good average speed throughout the trip, he's traveling at a very slow average velocity. This is a good example of how velocity and speed can actually be quite different for the same trip. This is because average velocity is how fast you are traveling from your start point. If you're running around a lot but not getting particularly far from where you started, your velocity is not going to be very fast. One more example, and this one's a little bit trickier. A car travels at 100 meters per second for 25 seconds, and then slows to travel 50 meters per second for 75 seconds. What is the average speed of the car? Well, the first thing you're going to want to do, and it's the first thing most students do, is this. The first thing you're going to want to do is calculate V average equals 100 plus 50 divided by 2, because that's how you've always calculated average. But this isn't going to work. Don't do this. This would work if they're traveling for the same amount of time, the two speeds, but they're not. The car spends more time traveling at the slower speed. It spends more time at 50 meters per second than at 100 meters per second. So the formula wouldn't work like that. Instead, you need to find the total distance. This is because the formula specifies that the average speed is total distance over total time. We can rearrange v equals d over t to get d equals vt. The distance traveled in 100 meters, then, is 100 meters per second times 25 seconds. This is 2,500 meters traveled at 100 meters per second. The distance traveled for the 50 meters per second is 50 meters per second times 75 seconds. And this equals 3,750 meters. So the total distance is 2,500 meters plus 3,750 meters. This equals 6,250 meters. So the average velocity, total distance over total time, average speed, is 6,250 meters divided by total time, which is 25, plus 75 seconds. This equals 63 meters per second, which is the average speed for the trip. Now, often in physics, we'll actually just look at constant speed situations, even though they're not really realistic in real life. And these are defined as uniform speed. Uniform speed is when an object travels at the same rate without changing speed, without changing direction. Same speed, same direction is uniform motion. For example, a car traveling in a straight line on cruise control would be traveling with fairly good example of uniform motion or uniform speed. In this case, if an object is traveling with constant speed. We have a special case. Then speed equals velocity. They're the same thing. And this is because there is no direction if it's traveling uniformly. There's no direction change, so velocity would end up being the same as speed. Also, the average velocity in this case would be equal to just the velocity, or the speed, and that's equal to d over t.